Attendance is good. Today, we're going to talk a little bit more about arrays, recap what we learned on Wednesday, really just make sure people are comfortable. Then we're going to talk about solving tough problems in general. In talking to students, I've generally noticed an uptick in perceived difficulty for the class. Definitely since the midterm, we're doing much harder topics than what we were doing before. And with topics before the midterm, we could build up. So with like if statements, we could just learn the if. Then we could add else if. Then we could add else. Now with the material we're learning, it's hard to break it down like that. Like I essentially have to teach how to build a function, and then I just have to let you build functions. Like there isn't an intermediate step where I can say like, let's only learn how to write half a function. I essentially have to teach all of it, and then it's kind of up to you all to practice, but it is a big leap. And so I want to take some time in today's class to talk about how we solve tough problems and using good habits when trying to attempt these harder problems. Then we're going to head outside to do some activities. Some are just fun, some are related to arrays, and then we'll come back and code some of the stuff that we practiced outside. Any questions before we get started? Okay, so arrays recap. First, does anyone remember the definition of a variable? What are some of the key components? So uniquely named, it's a placeholder, so it holds some data. And how much data does it hold?
As much as you want, or singles.
Yeah, so variables can only hold one piece of data. Arrays are the same, but so arrays are essentially the same definition, but what changes with arrays? Yes, they can hold multiple pieces of data. So essentially an array is almost like a collection of variables. Each element in the array is essentially like a variable. So like when we had our array, if we had like 3 elements in the array and they held the numbers like 5, 8, 2, each of these boxes is like one variable. And so for each of these boxes, anything we can do to a variable, we can do for each of these elements. We call it an element if it's one part of the array. And so if we wanted to get this element, let's say our array was called ARR, how could we get this first element here?
It would be the name of the array with the index of 1.
Yeah, and or in this case, if we want this one,
or 0.
Yeah,
0.
so we always start counting at 0. So this is essentially like a variable. We could have had another variable that's, whatever you want, but anything you could do with a variable, you can do with this array of 0. So we could have array of 0 be equal to something. If we wanted to, we could use array of 0 in a calculation and add 2 to it, and then store that result in a variable. Anything you can do with a variable, you can do with an element of an array. So first, we need to talk about how to define an array. Again, looks similar to a variable, but what's the difference? Sorry, I just didn't hear it.
What was your question again?
What's the difference between a variable definition and an array definition?
It's still uniquely named, but it just holds multiple pieces of data.
Yep, but in terms of syntax?
Oh, yeah.
Yeah, so if we were defining a variable, it would just look like this, like int age. Now we add this square bracket and we put in the size of the array, right? Anytime that we use ages later in this code and we use square brackets, it's going to refer to the index. Like when we used it in this example, this is referring to the index. It's not saying this array is size 0. This is saying the index. But the first time that we use square brackets, it's to say what the size is. Okay, so I'm going to have you all define 2 things. First, I want you to just define a planet variable. So just a normal variable, how would we define that? We're not going to set this value to it. We'll have you 2 together here. Sandra, John here. Kalik and Mark. We'll have Kylan if you're okay moving up here with CJ. We'll have you 3 together here. You together here. DJ or Kylan, whoever wants to move over, partner up.
So there's a difference between
Yeah, so just defining it. We're not assigning any values to it. Just define, if we want to define a variable, how do we do that? And then if we want to define an array, how do we do that? Think about what the data type should be for that.
For the first one, we're just doing the individual variable. That would just be the string.
Yep.
In this case.
So 8 for right now, and then it would be 7. Or what is it? 7.
Like it would store the name. So both of them are storing names of a planet. So the first one's just storing the name of one planet. The second one would be an array of all 8 planets.
So that, for the array, it would be string.
What is the, so I know we start counting from 0. So planet 7 would give us the last element, but if we're doing the size, it would be 8. And then don't forget semicolons. Cool. And then typically more browsing, so you typically call this like planets with an S, just so that it's clear that we'd be having multiple planets.
So it wouldn't affect,
It wouldn't affect the code, but like it just gets that some regular code, they would know like this is like multiple planets. Okay, cool. I think people's answers look good. Let's bring it back. So planet variable, what would that look like? All right, string planet, and then the array of 8 planets. Okay, and one thing that I just talked about with the previous group, in naming these, again, you can name it whatever you want, but typically for arrays, we'll typically make them plural. It's just kind of a good style thing, because now if someone looks at your code, they'll know we're talking about multiple planets, as opposed to just one. Cool. One thing also, like one of the groups had put 7 in here. It's true that the last element would be planets of 7, but when we define the array, we're just giving the total size. So if there's 8 planets total, it should be 8 in the brackets. Okay. Yeah, so it would be 8 here. So string planet's 8. Any questions here? Okay. Next thing we learned with arrays is initialization. So if we had like 8 planets, how would we actually fill in all those values? We can do it all in one line. So in this example, we still say the data type, we say the name of the variable, we say the size, and then we can put it's equal to, and whatever's in these curly braces is going to be assigned to each element in the array. So this 25 is going to go in the 0th index, this 9 is going to go in the 1st index, this 18 is going to go in the 2nd index. Okay. I'll leave this up for a sec. Any questions?
With arrays, you start at 1 instead of 0, right?
Like the index, or
Yeah.
Array index will also start at 0.
So then when it says in ages with the bracket 3, oh, that's just saying how many. Okay, I get it there.
Yeah, so this is the size. So the first square bracket when you define it is just the size, and the size is always going to be like the total count. Yeah, it is slightly annoying that they kind of use 2 different counting systems, but it's just how it works, I guess. All right. Other questions? Okay. Cool. So in your groups again, I'll have you initialize these 2 things. So on the same line, create a planet variable that is also going to be equal to the value Earth. And then for your array, you can have it be equal to any 3 planets that you want. So I'll give groups a couple minutes to work on that. John, you can go down here. right now without the quotes, it's gonna think Earth is
Oh, that's
a
what
variable. Remember, we need double quotes so that it knows that we're dealing with string literals and not a variable. Cool. Okay. You guys are good here? Cool. Sweet. I think people's answers look good. So yeah, planet variable with value Earth. I think I saw it for most people. String planet is equal to Earth. I'm missing the semicolon here. So add the semicolon at the end. And then an array of 3 planets will look similar. So string planets of 3 is equal to, and then remember, if we want these to be actual string values, we need quotes around each of them. Yep. All right. Any questions here? Okay. Final slide I have here for arrays is modification. So on this first line, we do the initialization. We set these values to 25, 9, and 18. What happens? So first off, this square bracket, what is this referring to?
The size.
Size of the array. What are these square brackets referring to?
Index.
The index. So what is this statement saying?
One,
9,
eight, 12.
9, or now we're at the second.
Yeah.
spot.
So the element at index 1 should be changed to 12. Yep. How about this one? What is this one saying?
Should be, 2, 18, 13.
Yeah, so what's stored at element 2? 18. So we're adding 3 to it, and then we're assigning it back. So this 9 is going to change to a 12. This 18 is going to change to a 21. Question? Yeah.
So I'm curious, could you possibly do like int age is 3, right? And then like kind of like this is like take off the curly braces,
Mhm.
like don't do the curly braces,
Yeah.
and then like do like int age is 1 equals 12.
Yes.
Int age is 2.
If you didn't have the initialization, all of these would be like question marks. So here, they're all just some random values. And then you would have to go in below and say like ages of 0 is equal to this. Ages of 1 is equal to this. It's just much slower to have to go and do each one at a time, which is why we have this option to do it with the curly braces and do all of them at the same time. Okay. But when we do like CIN values, like when we ask the user like enter 5 numbers and then we CIN each time, that's doing it that way. Like we just define it and then we CIN 1 value at a time into the array, which we do in lab. So if you haven't been to lab yet, you'll see it in lab. Okay, any questions on arrays? Again, lab 9 today at 4 p.m. Lab attendance on Wednesday was less than usual, so I expect a lot more people in for lab today. We can go over the slides all we want, but until you actually come and do the problems with arrays and figure out where you actually have questions, it's not really going to make complete sense. Like you have to come and actually practice it. So please come in today for lab at 4 p.m. if you haven't already. All right, you don't have to write this down, but in groups, I want you to talk about these 3 problems. When you see a problem that looks hard, what are your first steps? So I kind of want you to talk about that. What do you do when you first see a hard problem? Then after you've coded, if the code doesn't work, what are your steps to try to fix it? And then just generally any tips or habits that have helped you. So I'll give groups a few minutes to discuss. Again, you don't have to write it down, more just a conversation. And I'll kind of sit in on different groups.
I think I really try to take it down. I do like some mistakes. I forget I always check that out first. Tips that have helped me. Like I said, like kind of breaking school, breaking down. Like the last lab, last problem, like 2 problems combined. I was like, like when you break it down a little bit more, look at it in sections.
I think the general feedback with me, for the most part, is like every time I put it together, like work, but it works, I'm just first
right now.
example of what I was scratching.
It's wherever the line of code is, and I'll put like, see all the specific stuff to check for like which part is not working properly. Then once it's a try to make problems as easy as possible. Find the easiest solution first, and then from there, if you have more complex solutions like that, then you can implement those.
Okay. Cool. Share your final thoughts. Okay, I heard some really good points, and I kind of just want to crowdsource it so that people can hear other things that their peers are doing and can maybe try certain strategies if they want. So, okay, you see a hard problem. What are generally your first steps?
Read the description thoroughly.
Yes, read the description thoroughly. And what are you trying to do when you read the description? Like, what information are you trying to get from there?
What you're supposed to put into the code.
Yeah, so it's kind of like you're essentially trying to figure out, like, especially with functions. So I'll try to think about this in the context of functions. You're trying to think, like, what information do you need to provide or get from the user? And then, like, with that information, like, what are you trying to calculate? Like, every problem you're trying to calculate something or do something, right? So, like, what is the end goal that you're trying to solve? I think if you know what your starting point is and you know what your ending point is, and those are very clear, that can make it easier to figure out what you have to do in the middle part. Okay, so figuring out your start and end goal. All right, other ideas?
Put it in English.
Yeah, so thinking about the problem in English terms. So especially when we learn all this new syntax with like arrays and functions and for loops, it can kind of be overwhelming. But the nice thing with coding is it maps to English pretty well. Like sometimes I'll ask a student for the like height problem for the roller coaster. I'll ask them like, what is this, we'll do the capitalization example. Like with is lower and to lower and is upper, it's confusing to think about it in terms of code. But I asked a student like, what happens when the letter is a capital H? And they said, if the letter is capitalized, then we want to make it to lowercase. And I said, okay, just take what you just said. Like if letter is capitalized, make it to lowercase. So then now once you have that, now you can see what code maps to it. So because the student said if, you know you have to put the keyword if. You know you're going to use an if statement because you said if in English. So if, and then the function is upper, then in the code for that if statement, we can use the to lower function. So thinking about it in terms of English terms, that will help you know whether you need a loop, whether you need an if statement. Yep. All right, other things. I think those are probably the main two big ones. Cool. All right, next question. What to do when the code runs incorrectly? I feel like students generally sometimes have a good game plan, they start coding, and then they get either an error or they get stuck. What do you do in these cases?
If there's an error, like you go to a line that says,
Yeah, so let's do the error case first. If error, go to line
and then try
over
to
there.
see what's wrong with it and fix it.
Yep. So generally when there's an error, it will typically point you to the correct line. Sometimes it might be like a few lines off if you've forgotten like a semicolon somewhere earlier, but in most cases it will take you to the right line. Yep.
So if there's multiple errors, always solve from the top up.
Yep.
The top down.
That's a good point. So in your console output, like scroll to the top of the output and look for the word error. Sometimes there's just like a lot of stuff that gets printed, but usually it'll say the keyword error somewhere and it'll tell you the line. So scroll through your output and try to find what the error is. Cool. All right, how about if you're just generally stuck on how to proceed?
Network.
What?
Network.
Network, so like you can ask, you're saying like ask friends or search online? Yeah, so ask friends or look online. With this one, if you're asking a friend, like don't look at their code because that won't help you actually comprehend it. Like you can ask them to maybe look at your code and give a hint if they can help you figure out what the problem is, but don't just look at someone's code and copy it. Yep, other question?
Use comments and see out statements to figure out
Yes.
which individual lines of code are valid.
Okay, this is the one that I didn't emphasize early enough in the semester, and I really wish I did. I feel like sometimes students don't know at a given part in their code what the value actually is for a variable. So you can just see out a variable, even though your final output isn't going to print out that variable at that line, just see out the variable to see what value is stored there. And you might find that the variable doesn't actually have the value that you want. This oftentimes happens when people forget to set like num guess is equal to 0 or total equal to 0. If you just print out total somewhere in your code, you would then find, oh, I forgot to initialize the variable, right? So this is probably my biggest takeaway from today. Use cout statements if you're not sure what values your code has, okay? Anything else?
Look at similar codes you've done.
Yes.
If there's anything
Look at previous problems. Literally when I create these problems, like I create the lab and then I create the homework to be slightly harder. So in this week for lab, I do a problem where you have to create a function that sums the values of the array. And then for homework, I do a problem where you have to find the average of the numbers in an array. The average is slightly harder because you have to sum all the values and then divide it. So if you're stuck, you can look back at the sum problem. Part of why we do all these problems, it's pattern recognition. CS is pattern recognition. So we do enough problems that you kind of subconsciously memorize the pattern. And if you haven't memorized the pattern yet, you have all your code from all your previous assignments. You can go back and look at it, right? The one thing I'm gonna add is, at the end when you're stuck, look at the description, like reread the description. So sometimes when you first read the description, I put a lot of information and a lot of it doesn't make sense initially. After you write some code, then you should go back and read the description again, because then one of those hints in the description might actually make sense. Yep. All right, final slide. Any general tips or good habits that people have found useful?
slow down.
Nice. Slow down. Part of the reason why I want people to start the homework earlier, if you're doing the homework at 11 p.m. the night it's due, you don't have time to slow down and think about it. Oftentimes when it's late at night and I can't solve something, I'll just go to sleep. And somehow during the night, because I'm like subconsciously thinking about the problem, when I wake up in the morning, sometimes you have something to try. But you can only do that if you start the problem earlier in the week, right? It doesn't work if you're staying up super late at night. So slow down. It can even help. Just look, when you wake up in the morning, just look at one problem, even though you're not going to solve it then. Just look at the problem so that you're at least like thinking about it in the back of your mind during the day, right? Slow down, give yourself more time to think about the problem. Okay, other things? Yep.
If you have a problem that you just can't solve at all, sometimes working on different projects will give you perspective as to solve that problem later.
Yeah, so working on other problems. So you don't have to do the homework problems in order. Some of them you do. If you're using a function, then you do have to do them in order. But a lot of times they're unrelated. So you can try working on a different problem and then come back to the one you're stuck on later. Cool. Other ideas? Cool. All right, I think this is a good overall. All right, final thing, midpoint survey results. Thank you all for filling it out. People are feeling pretty confident as coders. We see a little bit of a drop off in these next two categories. The one that I want to focus on today, I think by the end of the semester, like I've taught all the classes here because Dr. Watkins has been out, so I've been filling in for his classes. I think if you feel comfortable with the material, like you are prepared for the other classes, but I think it will be more practice it's needed in this next month. And then for this bottom one, feel prepared for coding interviews. You can either fill this out on your phone or on your laptop. Only fill it out if you would actually attend, because I'm going to try to choose a time that actually works for most students. So one thing we're going to start incorporating are homework parties. So if you think that it would be useful to come and kind of like a lab setting. I feel like students work really well in lab. When you hear hints around the room, you're in a focused setting for an hour and you can just work. I found students do well. And so we're going to try to incorporate that, but for homeworks. So if you're interested in that, like maybe take a picture now and at some point today, fill out this link. Yeah.
Could you add them to the EdStem?
Yes, I will make an EdStem post so you can access it there. They're essentially like when to meet. So just generally, when are you free during the week that you would want to come in and work on this homework party? And or if you're interested in doing weekly interview prep and doing more challenging problems, we're gonna get together like a little cohort for that and do once a week, just work on leak code problems, give tips generally how to do interview problems. Yep. Okay, let's go outside, get some fresh air. You can leave your stuff, but bring a jacket, it might be cold. Let me get.
I figured out I don't have the industry one. I just have a collegiate. And then you gotta also do an interview with.
Like meet up in person?
Yeah, and you also have to do an interview with Carrot.
I can't just do a Zoom call.
Oh yeah, you do have to do an interview with them. See, I set up one.
I'm doing it right now. We're trying to do it on the weekend. Because I know.
Are we leaving the spot?
Oh yeah, we are coming back. I'm sure.
I'm about to knock it off. I'm about to go back home. I'm a little bit of clarity.
swap elements in the array. Let's open up the visualizer. Okay, so let's create an array of ints. How can we define and initialize the array?
Int array.
Okay, I'll call it nums just because it's storing nums. And then what goes here?
Square bracket.
Okay, let's say we had, we'll do 5 elements. Actually, we'll just do 3 elements like our example. And we'll have it be the values 1, 3, we'll do 5, 3, 1. Okay? So we want to swap the 5 and the 1 and make the array go in ascending order. So in English, what is our general, what are we trying to do in order to do this swap?
Trying to move 5
Mhm.
so that there's no place in index of 0.
Yeah, so we want to switch 5 and 1. If we just tried to do it like, so what element is 5 in, or what index?
0.
Right, so oftentimes a lot of people would think you can just do it like this, like num0 is equal to, yeah, num2. And then just say num2 is equal to num0. In our example outside, that was essentially like when both people were trying to move at the same time. If we were to run this code though, nums. Is there one more? Oh, 2. Okay. So we initialize the array, so it has the values 5, 3, and 1. What happens on line 8? Num0 is equal to nums2.
So
Nums two.
it'll be 5, 3, 5.
Yeah, or num0. So we're reassigning num0.
Oh, so it can be 1, 1, 3, 1.
Yeah, so we're gonna have 1, 3, 1. So it looks like we're on the right track. But then what happens on this line? We're trying to reassign nums2.
Oh, it's gonna make it 1 because
It's just gonna be 1.
Yeah.
Exactly. So we've essentially lost the 5 if we try to do it like this. Ideally, both lines would happen at the same time. So the 5 goes here while the 1 goes here. But in computer science, only one line of code can run at a time. Yeah.
could you like probably put like num2 is equal to num0 plus 4 because of the 1?
That would only work though if you knew the number was 5.
Oh.
Like we want this to work for any set of numbers. Yeah. So this is the same problem that we faced outside. And how did we fix it? Yeah, we like brought in Jekyllin to serve as like this temporary variable. So oftentimes the variable that's used for this style of problem is called like temp. And so this is just going to temporarily hold a value that will allow us to do the swap. So we saw in this example, when we had num0 is equal to nums2, we were losing the value at num0. So what can we have temp be equal to? Yeah, so before we reassign the value in num0, that's like just giving the note card to Jekyllin, just like temporarily save this value for us. And then at the end of the problem, Jekyllin gave his value over to Khalik. So this assignment statement, what should go here? The value in temp. Okay? So now if we're to run this, so still the same array, but now what is the value of temp going to be? 5. Num0 is equal to nums2, so what is num0 going to become? 1. And now we still have the value 5 because we stored it in this temporary variable. So now when we have nums2 is equal to temp, now we get 1, 3, 5. All right. Any questions here? Cool. So this is, I mean, we swap elements. Definitely when we do sorting algorithms next week, the algorithm is going to require us to swap different elements in the array so we can make it go in ascending order. So we'll use this kind of concept in that, using a temporary variable to store the data. but it's really more a bigger testament to computer science in general that only one line of code can run at a time. And so if you're moving data, you can't move two pieces at the same time. You have to store one of them elsewhere before you try to swap them. Yep. Cool. So I'll copy that code into the slides. Again, homework 8 due on Monday. Lab 9 today at 4. Please come into lab today at 4, especially if you didn't come in on Wednesday. Super critical lab to practice arrays. The lectures will only make sense if we actually get practice with it in person. So lab today at 4. Or if you've already finished lab and you just want help on homework, you can also come in at 4. I won't have office hours today, so really the lab at 4, and if people want to stay after, we can spend time there. Yep. Cool. Thanks, everyone.